Alright, hi you guys. Today we'll be talking about solving rational equations. And with rational equations, there's two methods, and it's kind of like with solving systems of equations. You're presented with four methods: graphing, oh my gosh, why am I forgetting this? Graphing, substitution, elimination, and matrices. Okay, and there's four different methods, but you only technically need to use one, and sometimes it's a convenience to use one over the other, but technically, as long as you get them all going the same way, you can use one all the time. Same thing here with rational equations. I'm going to show you two methods. I want you to pick the best. I personally like one of them. You'll see me only use that from here on out. But for example, in this example, I will show you both methods so you can decide for yourself. Okay, so the first method, simplify one side until it is a fraction, then cross multiply to solve. Okay, now if they're already one fraction on both sides, just cross multiply and you're done. But on this one, I'm going to go ahead and simplify this one. This is a rational expression. I'm going to add these two fractions. First off, I got to find the common denominator between these two, and the common denominator is going to be 6. Okay, because 6 goes into 6 and 2 goes into 6 as well. So what I need to do is I need to multiply this side by 3. Multiply the top and bottom by 3. Okay, now technically you can multiply this by 6 over 6 and this by 2 over 2, but to get 12 as your common denominator. But this is easy. I'm just going to go with least common denominator. Okay. All right, and so what I'm dealing with is 3a over 6. Okay, so I'm going to go ahead and add these two together. So that gets me 5a plus 1 over 6. Okay, and here's my fraction bar. Alright, and then I have a minus 1 over 3. Okay. Alright, so I've gotten down to one fraction each, so I'm going to go ahead and cross multiply. Okay, so I'm going to cross multiply, and I get 15a plus 3 equals 6a minus 6. Okay. Alright, now I'm going to minus 6 from both sides and minus 3. And so I get 9a equals negative 9. Okay, and a equals negative 1. Alright, now when I get my answer, I do need to check it, and I do need to see if it does give me any restrictions. Now, because all my denominators are already numbers, it's not going to be an issue, so when I check it, it should work out. Okay, so that's method number 1. Okay, method number 2 in my crappy mouse drawing, okay, is find the common denominator first between all of the fractions, then multiply everything by the common denominator, simplifying as you go. And when you're done, you'll have an equation without fractions to solve. Okay, so our common denominator between all the fractions is going to be 6, which makes sense because you got 6, 2, and 3, and the common denominator is 6. So I'm going to multiply everything by that. Okay, and so what I've done is I've multiplied everything by that. Now I'm going to simplify as I go, and simplifying is just seeing what common factors I have. So these both, one goes in each, okay, these 2 goes into each, leaving a 3. Alright, and this one goes in twice, and this one's leaving a 1. Okay. Alright, and so what I'm left with is 2a plus 1 plus 3a equals 2a minus 2. And that's after I distribute the 2 over here. Okay? Alright, so it's a really nice setup equation, okay? Alright, so I set it up. I'm going to... Well, technically I can minus the 2a's. Alright, I have two 2a's one on each side, so those will cancel out if I minus the 2a's. Okay, and if I minus the 1, I should get 3a equals negative 3. Okay, and then a equals negative 1. I actually did a video earlier where I made up my own problem, and then I tried to do the two different methods, and it did not work out. Let me tell you what. So you're seeing take 2. So this is the best way to do it. The way I personally like is this second method. I like to just find the common denominator first and then multiply everything by it and then just simplify just a simple equation. Cross multiplying, yeah, but in the beginning you can get stuff messed up. I just like the second method, so whatever. Okay, now taking a look at this one, I'm going to solve this by the common denominator. Okay, so the common denominator, now if you notice right here, if I factor out this one, if I factor out an n, I get n times n plus 1. Okay, well, guess what? n plus 1, n times n plus 1. A common denominator would be, well, technically I've said before, multiply everything together, but look at this. This is just the product of these two, so why not just go ahead and use that common denominator? So the common denominator is going to be n times n plus 1. Okay? Alright, so what I'm going to do is multiply everything by that. Okay, so here is what happens when I multiply everything by it. I'm going to start canceling out stuff. Okay, well, not canceling, but simplifying, like I've always said, simplifying. So the ends simplify, even I have to catch myself saying it. These n plus 1 simplify to 1s, okay, and then guess what? Everything over here just simplifies. It's beautiful how it works. Okay, so what I'm left with, and I'm going to distribute as I go, 2n plus 2 plus n squared plus 2n equals negative 2. Okay, so I have everything all set up. So what I'm going to do is bring everything over to the left side, and I have n squared plus 4n plus 4 equals 0. Okay, that's a perfect square trinomial, so that's n plus 2 equals 0. Okay, and I simplify that, and n should equal negative 2. Okay. Alright, now when I check my work and plug in n, I should find out that where I plug it, I'm not going to have any issues. I'm not going to have any restrictions, and I'm not going to have any kind of paradoxes created. So please understand, when you solve this stuff, you do need to check it just to check. See if you're making the right choice and everything. Alright. Now, this next problem we're talking about is from purplemath.com. It's a really great website to look at, especially when you're in Algebra 1 or Algebra 2, because it's basically all algebra. A little bit of calculus, a little bit of trig. But here is a word problem that does use equations or rational equations to solve. And it's a word problem. So one pipe can fill a pool 1.25 times faster than a second pipe. When both pipes are open, they fill the pool in 5 hours. And how long will it take to fill the pool if only the slower pipe is used? So first off, you need to convert to rates. Alright, so hours to complete the job. The fast pipe completes it in F amount of hours. The slow pipe completes it in 1.25 more hours than F. So that's why we have the 1.25 F. Together, that's about 5 hours. Okay. Alright, now completed per hour. Right, the fast pipe, it's an inverse relationship. So the fast pipe is 1 over F. Okay, the slow pipe is 1 over 1.25 F, and together it's going to be 1/5. So that's the trick when you're working with these ones. Whatever the rate you are, or whatever the hours you are taking to do this, okay, the rate completed per hour is 1 divided by that time. Okay, so that's a really nice thing to just think about, just when you're doing this type of stuff. Okay, so if we add their labor together, or the two pipes together, it should look like this. Okay, 1 over F plus 1 over 1.25 F equals 1/5. Okay, now if we multiply everything by 5, well, 5F. Okay, so if we multiply everything by 5F, we get 5 plus, let me get my calculator. 5F would be the common denominator, just so you know. Common denominator would be 5F. Okay. Alright, and so when I divide the 5F divided by 1.25, I should get about 4. I just wanted to make sure I did that correctly. Equals, All right, and then 5f divided by 5 is just f. Okay, so the total amount of time it should take the first pipe is just 9 hours. Okay, now if I wanted to find the slower pipe, all I would do is plug into the equation. Okay, well, shoot, I know that the slow pipe is 1.25 times f, so it's 1.25 times 9, which is 11.25 hours. So the actual slow pipe takes about 11.25 hours.